Okay, so here we go. Binomial distribution versus Poisson distribution, right? By the way, this entire unit is all discrete, as in like counting. Next unit is going to be continuous, where it's going to be like in a time interval or measurement. Yeah, still fun, still lots of fun. Okay, here we go. Yeah, all right. So let's say you get a job as the editor of a magazine, something like the Mendelfloss magazine. That'd be cool. Anyway, so Sandra is the editor. She proofreads 100 pages or 800 pages, 880 pages of a textbook, and then she has to count the number of times she finds a mistake on the book, up to like 10 mistakes on the book. So X is the number of errors on the page, and then she just calculates the frequency, right? Something like this is describing a Poisson model, where it's kind of like an interval, anywhere from 0 to 10 errors, like an interval of mistakes. Yeah? Good old Poisson.
So they're just errors.
That'd be terrible. Well, I mean,
have you ever seen our chem textbook?
There are actually errors in this textbook,
Yeah.
right? There's an error on your test! All right, so here we go. So the Poisson distribution has the following formula, right? It actually takes in the natural number E. That's what E is. And in Poisson, all you need to know is the mean of the number of events. So M is the mean of the total number of events. So in Poisson, it's going to say like X is such that it's a Poisson distribution, so it's going to say Po, and then it's going to tell you the mean. That's all you need to know. That's it. Yay? Oh, I already put that notation down. Yeah. Okay? So the difference between binomial, right? Talk to me about binomial. What do you remember?
There's only two.
Two. Yeah, there's two outcomes. Right? It's either success, suck. How do you spell success? C-E, like that, or failure. All right, it's math class. Here we go. It's success or failure, right? And then you have the notation that X is such that it's a binomial, and then it's the number of trials, and then the possibilities. So the formula was like N choose X. And how did it go? Like P to the X, and then 1 minus P or Q to the X minus 1. Right? Does that look familiar? Yeah. So it's two outcomes, success or failure. So that's binomial. Is it N?
N minus X.
N minus X. Thank you. Yeah, my bad. N minus X. I was thinking the P minus 1 part, 1 minus P, which is Q, the failures. Yay? Okay? Versus Poisson, right? In Poisson, it's outcomes in a given interval. With a mean number of outcomes. Okay, so again, this one goes X such that it's a Poisson distribution with some mean, which has the formula e to the negative m, and then it goes m to the x over x factorial. Is that true? I think so. I think that's the formula. I could be wrong. I don't know. Yeah. Okay. So let's calculate some Poisson. Ready? Here we go. The number of demands for a taxi firm is the Poisson distributed with, on average, 4 demands in 30 minutes. So a taxi can get up to 4 demands in 30 minutes. Use the probability to find all those things. So for example, no demands in 30 minutes. So if you're actually using the 30 minutes, then we know our mean is going to be how many demands in 30 minutes? Average is 4, right? And so this would have a Poisson distribution of 4, right? So if you're looking for the probability that x equals no demands, so x equals 0, then it would just be e to the negative 4 times 4 to the 0 over 0 factorial. Got a calculator? Oh yeah, math. Go to math, and then. Oh, 0 factorial is 1, always. And then like 1 factorial would be 1, and then 2 factorial would be 2 times 1, and 3 factorial would be 3 times 2 times 1. Yeah? No. Yeah, because you can't divide by 0. Yes. Yeah. Yes. Yes. How would you multiply it out? It would just you just have to have that common. Just everybody knows 0 factorial is 1. Yeah, because otherwise you'd be dividing by 0, and that's not defined. Right. There is a way to prove it, but I don't know if I want to right now. Yeah. All right. Let's say you have 1 hour time interval. What would the mean number of demands be in 1 hour? It would be 8. 4 plus 4 is 8. So in this case, the mean would be 8. So x would have a Poisson distribution of 8. Yeah. 1 demand in 1 hour means you're looking for x is equal to 1. So that would be e to the negative 8 times 8 to the first power over 1 factorial. Oh my gosh. 0027, or so I'm going to go 68 just to say things. Is that okay? Yeah. Okay? Fewer than 2 demands in 15 minutes. So what would the mean number of demands be in just 15 minutes? It'd be 2. Yeah. So fewer than 2 means you're looking for a Poisson of 0 or plus, right? Poisson of 1. Okay? Yay. So this would be e to the negative 2, 2 to the 0 over 0 factorial, plus e to the negative 2, 2 to the 1 over 1 factorial. Yes, sir. Now, question, are you using Poisson CDF? Oh, okay. What a good time to stop and use the calculator. Right? Here we go. All right, let's recalculate these things, make sure we're good to go. Okay? Yeah. So there we go. If you go second distribution, and yeah, not Poisson. Okay, so you have Poisson CDF and Poisson PDF. For the first one, which one should we use? PDF, because it's equal to, so it's an actual point, right? So all it asks for is that, okay, so lambda is what the mean is. So our mean was 4, and our x value was 0. Hit the paste. Hey, good times, right? Yeah. Okay, let's do the last one. For this one, since it's everything from 0 up to 1, you could say that it's everything from x, yeah, less than or equal to 1. So instead of PDF, use CDF. So look at all these distributions. Oh my goodness. I think we learned how to do normal. All right, so for this one, our lambda was 2, but what would our x value be? 1, and hit the paste. How about that? How about that? It's a good time. And the good news is probability, probably paper too. Yeah. It's not bad. It's not bad. Okay. I can see your excitement bubbling. Here we go. All right. All right. Talked to Baze this morning. She's very friendly. Here we go. And knowledgeable. And knowledgeable. She's a good person to ask too, because her husband's a doctor at ODU, and so my husband's looking to get his doctorate in some type of science. So I'm trying to see if they can connect. Anyway, but basically good. Yeah, LinkedIn. Here we go. All right. The number of organic particles suspended in a volume of water from a particular pond follows a Poisson distribution with a mean of 0.2. Use your calculator to find. Ha, ha, ha. If you had a volume of 50 milliliters, what would you do to find the mean? It's 10. Hondro, so smart. Yeah. The mean is equal to 50 times 0.2, which would be 10. Right? And then fewer, so that means we'll have a Poisson distribution with a mean of 10. Fewer than 8 particles means that x has to be less than or equal to 7, right? Because it's fewer than 8 particles. So this would be a Poisson CDF, true? Because it's everything up to 7, right? Where does it go mean and then the number, right? So you're going to go 10, comma 7. That's it. Yes. 220. Done. To 3 seconds. Whichever. Yeah? Okay. Here we go. I want to change this one because we did a fewer one. Let's change it to more. Yeah, let's do more. Yay? Okay. Only reason why I do this. First of all, this needs a mean, first of all. So our mean is going to be 30 times 0.2, which is 6, which means x is a Poisson distribution with a mean of 6. Yeah? So wouldn't you agree that if x is fewer than 2, that is the same thing as 1 minus everything up to 2? Is that right? Yeah, everything up to and including 2. So P of x less than or equal to 2. Right? So in your calc, you just do 1 minus Poisson CDF 6 and 2. Huh? Yeah, yeah. Mhm. Uh-huh. Let me know when you know it. There it is. Yeah. So 0.938 to 3 sig figs. Yeah. All right. P.S. If you are writing all this down on your paper, all you have to write is like GDC. If you can write the Poisson CDF, but if you write GDC on a paper too, they'll know that you use the graphic display calculator. Yay? Yay! Good times. All right. Volume of 10 milliliters. It contains exactly 3 particles. So M is equal to. Yep. Okay, so x is a Poisson distribution with a mean of 2. Exactly 3 means P of x is exactly 3. Right? So on your calculator, it's going to be Poisson. PDF, thank you. That was the PDF. Is the difference, right? And then it goes 2, 3. 0.180. Yeah. Okay. So I know we had that chapter 33 practice, but I thought instead of doing that, we'll just combine the practices for Poisson and the binomial and also the regular distribution into a take-home quiz. So you have take-home quiz and you have the 6 questions as practice. We'll go over the take-home. Oh my goodness, here we go. We're gonna go over the take-home quiz and then the assignment next class, and then you'll have a little itty bitty test. Sound good? You know, itty bitty. Teeny weeny? I don't know. It's not gonna be bad. It's not gonna be bad. Yay? I'm pretty sure. Oh, I'm sorry. I lied. No, Tuesday. Nope. No, it looks like your test is gonna be Monday because we have a review and then a test. So that way you guys can catch up. So you guys can go for a little bit. Yeah? Yay! Okay. Here we go. Miss Abby wants to take a test today. This is awesome. Yes, love.